Hello everyone, welcome to my channel, and I'm Kyle Joseph Badua, and I'm here to discuss about maximum flow and shortest path. Now let us first understand what is maximum flow. Maximum flow is about finding the biggest amount of something like water, data, cars, people that can travel from a start point to an end point in a network without breaking any capacity limits. Let us also analyze what is shortest path. Shortest path is about finding the fastest or shortest route from one place to another. To clarify everything, let us make a problem for both, and let us first solve a problem from Maximum Flow by Ford Fulkerson. Let's use this diagram for example. First thing to do is let's find our starting point and our finishing point. After finding those 2 points, let us start with step 1. Choose any path from the start to end of a network flow. I chose the 1, 2, and 6 path. After choosing a path, let us start with step 2. Find the arc with the lowest flow capacity that is available going from the source to the sink. And in this path, we have the 3 and 2 for the choices. And we will choose the 2 because the 2 is the lowest. Now let's move on to the step 3. The lowest from capacity is subtracted from the direction of source to sink, while in reverse direction it is added. As you can see, we change the value of the capacity according to the rule that is given. After completing the subtraction and addition in the chosen path, let us now go to the iteration method. As you can see, we choose another path to do the same step 1 to step 4 method that we do in the iteration 1. After the iteration, we can now see that the value of the capacity flow has now changed. And with that, we can see that every path has a zero capacity flow. That means we can now find the maximum flow capacity for the given network model by summing up all the lowest flow capacity. Now let's go to the problem number 2, which is the shortest path. We'll use this data flow diagram for an example. First thing to do is give the starting node a value of 0. And on step number 2, put a box on the node you are at. And in step number 3, travel off edges from the node and label the connected nodes of the value of travel if there is no current value or the value is already there and higher than the new value. Let's now put 6 as a value of the B and 7 as the value of the C. Now let's choose which is lesser, the 6 or the 7. Now that our box is in number 6, let's find the value of D, C, and E. Now the value of C is 7, and D is 8, and E is 11. And basically we choose C, which has a value of 7 because it is the lowest. And now that we are on C, let's go check if what's the value of D and the F. As we can see, we choose D because the value of D is lesser than the value of F. Same with the E and F, we choose E because the value of E is lesser than the value of F, which is 13, and E is 11. Now that the value of G is 18 and the value of F is 13, we chose F because the value of F is lesser than the value of G. And F to G because it is the last node that we have in this diagram. After having those box values, we can now find the shortest path of this diagram. Now the pattern will be reversed. Let's start from the G to A. As you can see, what is the smallest value that is linked in G? We have a choices from E and F, but we chose E because E has a value of 11 and F is 13. Again, we'll do that until we find the smallest path of this diagram. Now we have the shortest path of this diagram, which is the A, B, E, and G. That's all for today. I hope you learned something. Thank you for watching and goodbye, everyone.